Hey everybody, Zachariah J here again. This is just an extra fun little math problem that a friend of mine posted on Facebook. He's currently going to school to be an aerospace engineer while I'm trying to be a mechanical engineer, but obviously the math still works the same on both sides. And since he posted this problem to check his work, to have some friends help him out with it to make sure he got it right, it was a fun little problem, so I thought I'd share it with you guys. So here's the problem. How long is line segment AB? And you're given the radius of these three circles inside this rectangle. I encourage you to pause the video, resketch the problem, and see if you can solve it for yourself. There's probably a few different ways to do this, but I'll show you the way that I feel like was the simplest, and it was also my friend Gil's method of solving the problem as well. So pause the video, try it out for yourself, and then come back and see how I solved it. So the first thing I look at is this bottom circle has a radius of, or sorry, a diameter of 6 centimeters. Well, that tells us what two sides of the box are. I can drop an altitude from the center of this circle down to this diameter. Make this line straight here. And I know that since this is 6 centimeters across, let's get a little smaller pen here. This is half the radius of my middle circle, this distance. And since this is the center, that means half the radius of this circle at 6 centimeters is 3 centimeters. So if I take 6 centimeters and I subtract the other two segments that I know, which is 2 plus 3 is 5. So I take 6 minus 5. That means what I'm left over in the middle is 1 centimeter. So the segment from this altitude I dropped to the center of the circle is 1 centimeter. Now, this portion I can figure out because I assume that all these circles are tangential, meaning they touch at exactly one point. So basically, I've created a triangle. I'm trying to create a straight line, and I can't do it at the moment, but there we go. I'll do it the more difficult way, or easy way, as I've just proved. Anyway, so this is a 90-degree triangle, or a right triangle, and I can basically use Pythagorean's theorem to figure this out because I know that these two sections are the radiuses because they touch at that one point there. Let me put this in a small. So this is 2 and this is 3. So combined together, my hypotenuse of this triangle is going to be 5. There you go. So again, I can use the Pythagorean's theorem to figure out how long this vertical section is. So Pythagorean theorem is a squared plus b squared is equal to c squared. And we know two of these components. So we know the 1 centimeter, so 1 squared plus b squared is equal to 5 squared, because I know that this is 5 here. So 5 squared. I don't know why I drew that other 5, but anyway. 1 squared is 1, plus b squared equals 5 squared is 25, so that's equal to 25. Subtract the 1 from both sides. We got b squared is equal to 24. Uh, not squared, just 24. There we go. And then square root of both sides would make b equal to the square root of 24. So now I know this portion from where this line would be segmented off of this middle circle to the b is square root of 24. That's how long this portion is. Now I need to know from A to that same point. So basically I can do pretty much the exact same thing because I know that these two circles again are tangential, touching at one point. Oops, let me get the big heavy weight. So half of this is going to be 1.5 and 2. There we go. And I know these lines are going to be difficult because it's going to try and snap to other stuff. So I'll try and make a couple straight lines over here. I'll just port them in. Come on. Yay, success. Get rid of these, and then I'll move these pieces over here. So basically, I'm dropping this altitude down, and I know in the sketch, this first line looks like it's just right at the edge of the 4 centimeter circle, but that's probably not true. And I'll show you why in a minute. But here is our right triangle for this one. And we can figure out what two of these sides are. Again, this is tangential, so there's the 1 point. So this radius is 1.5, and this radius is 2. So we add those two together, and we get 3.5. So our hypotenuse is 3.5. Now we need to figure out what is this portion. Well, again, remember this whole thing all the way across is 6 because it's the circle or the diameter of the circle below us. And this radius is 2, which is half of the 4. So we're going to do 6 minus 2. And then we're going to subtract this other segment, which is on this side, which is half the radius or half the diameter of what's above, which is 1.5. So 6 minus 2 minus 1.5, well, that's going to give us 2.5. So now we know, again, two sides of this right triangle. So again, we're going to use Pythagorean's theorems, a squared plus b squared equals c squared. And I'm going to use a as my variable this time. So a squared plus 2.5 squared is equal to 3.5 squared. Now 2.5 squared is 6.25. This is where I got those numbers from, these two guys here. So 2.5 times 2.5 is going to give us 6.5. So a squared plus 6.25, excuse me, is equal to 12.25, which is 3.5 squared. Now I'm going to subtract the 6.25 from both sides. Comes out to a nice even number, 6. And so a in the square root both sides, a is equal to square root of 6. So this upper portion of the line segment AB is square root of 6. So now I just need to add the two of these together. So square root of 24 plus square root of 6, and that will give me my answer. So line segment is equal to square root of 24 plus the square root of 6, which I put into a calculator. And that turns out to be 7.348, rounding to 3 decimal places. And since this has all been in centimeters, we'll put our centimeters here. And that is the final answer for this guy. So fun little brain teaser problem. Helps keep you in practice of a little bit of trigonometry type math. Thanks to Gil for posting this on Facebook. It was really fun to help check his work. I got to give him a little bit of a hard time because he didn't put his centimeters on there and he didn't round correctly, but it's always fun to give each other a little bit of a hard time. So anyway, hope you enjoyed and see you on the next problem.